This video shows how to transpose or rearrange an equation to obtain a single pronumeral or combination of pronumerals by itself on one side of the equal sign. The method involves performing operations on both sides of the equal sign. Sometimes we wish to transpose or rearrange an equation in order to get a certain pronumeral on its own. We say that we are making the pronumeral the subject of the equation. So for example, let's solve a plus b equals c, and we want to solve it for a. Now if we have a look at this equation here, what did we do to a? First thing was we added b to it, and that gave us the answer. So our first operation was plus b. So when we unpack this equation to get the letter a all by itself, the pronumeral a by itself, we want to undo what we've done. So the inverse operation to plus b will be minus b. And what we do to one side of the equation, we must do to the other side in order to keep it equivalent. So a plus b minus b on the left, well, plus b and minus b cancel out. 0, nothing. We're left with just a by itself on the left. On the right hand side, c minus b gives us c minus b. That's all we can do with it. End of story. So we've transposed this equation to make a the subject of the equation, and that a, the pronumeral a, is equal to the pronumeral c minus b. Next step, let's solve kh equals d for h. Okay, well kh means k times h is equal to d. What's the first thing we did to h? We multiplied it by k. So here we go, multiply by k. When we unpack this equation to get h by itself, we need to find the inverse operation to times k, which is divide k, and what we do to one side of the equation we must do to the other. Always do the same to both sides of the equation in order to keep it equivalent. K times h, 1k, well k divided by k is 1, it cancels out, we're left with just h on the left hand side, and on the right hand side d divided by k gives us d over k, and that's our solution. The pronumeral h is equal to the pronumerals d divided by or over k. Let's solve khm equals d for h. And what that means is we have h times k times m is equal to d. And we could write that as the operation we performed on h was simply to multiply it by the product km. Now the product km means the pronumeral k times the pronumeral m, and we just write that as km. So we'll treat it as a single block, which we can, it's just a product. Just like we can treat, for instance, 2 times 3 equals 6, while the product of 2 and 3 is 6, so we could imagine that we're just dealing with 6 here. So, the inverse operation to times km is divide km, so we're going to divide both sides of the equation by the product km. Product means multiply, the result of multiplying two objects together. So if we divide the left hand side by km, we must divide the right hand side by km. H km divided by km, well the km's cancel out, and we're left with just h on the left hand side. On the right hand side we have d divided by the product km is just d over km. So the pronumeral h is equal to the pronumerals d divided by the product of the pronumerals k and m. Let's solve the equation v equals u plus a times t for the product at. We just want this combination at by itself. Well, let's have a look at at. First thing we did to it was add u to it, and when we did that we ended up with v. So the operation we did was plus u. So when we undo this equation, when we unpack it to get at by itself, we need to get rid of that plus u, and the inverse operation for plus u is minus u. And again, what you do to one side of the equation, you must also do to the other side of the equation in order to keep it equivalent. So we have u minus u, which cancels out, disappears to 0, leaving us with at, and that's equal to, on the right, v minus u. So the product of the pronumerals a and t is equal to v minus u. Let's solve the same equation again, v equals u plus at for the letter or the pronumeral a. So let's have a look at this equation. We'll just rewrite it. U plus at is the same as at plus u. the order doesn't matter. Think of numbers. 2 plus 3 is the same as 3 plus 2. Alright, let's have a look at A. The first thing we did was multiply it by t, so times t. The next thing we did was plus u, and that's how we got v. So the first thing we're going to undo is the plus u. So the inverse operation for plus u is minus u. So there's minus u. But what we do to one side of the equation, we must also do to the other. So on the left-hand side, we have at, the product at, plus u minus u, or plus u minus u cancel out, leaving us with the product at. And on the right-hand side, we have v minus u. Now, the next operation to get the pronumeral a by itself is we have to deal with the times t here, times t. And the inverse operation for times t is divide t. So we divide both sides of the equation by t. The product at divided by t, well, this t and this t cancel out. T divided by t is 1, 1a. We just have a by itself. On the right-hand side, we have v minus u, all divided by t, if you like, there's brackets around there. V minus u, all of it, divided by t. So that a is equal to v minus u over t. Next one, let's solve ab over k minus rt equals w, and we want to solve it for b. So let's have a look at the equation again. Well, here's the pronumeral b. First thing we did was times it by a. Next thing we did was divide k, so we've got times a divide k, and then the last thing we did was subtract the product rt. Now, we could have done this, we could have said the first thing we did to b was divide k, then the next thing we did was times a. Times and multiplication are on the same level for the order of operations. So which one goes first doesn't matter, but let's just choose the times first. So first thing we did to b was times a, next was divide k, and the last thing was subtract the product rt to give us w. So here's the operations here. When we work backwards through this equation to get b by itself, we're going to have to unpack it, and the last thing we did was subtract rt. So the first thing we get rid of is minus rt. The inverse operation for minus the product rt is to add the product rt. Minus rt plus rt cancels out, disappears, 0, leaving us with ab over k on the left, ab over k on the left, and on the right hand side we have w plus rt. What we added to the left hand side, we must add to the right hand side to keep this equation equivalent, equal. So we're left with ab over k equals w plus rt. Next thing we're going to get rid of is the divide k. And the inverse operation for divide k is times k. So here we have times k on the left, but what we do to the left-hand side of an equation, we must also do to the right-hand side of the equation. So this whole object, w plus rt, is going to be times by k, hence the brackets. All of it, the whole thing, is times k, is times by k. Now on the left here, times k and divide k cancel out, because k divided by k is 1, so we're left with the product ab is equal to k times this bit in brackets. Next thing we want to get rid of is the times a, because remember we just want this b by itself. We don't want this times a here, so how do we get rid of times a? The inverse operation is divide a, so on the left if we divide by a, then we must also divide everything on the right by a as well, in order to keep this equation equal. Now on the left, a divided by a is 1, so we're just left with 1b, b, all by itself. And on the right hand side we're left with k times this object in brackets, w plus rt, over a. And that's our solution. B equals this object here. Alright, now in the description below this video is a link to a worksheet with questions for you to practice, and below that is another link with the solutions to the same questions.